Welcome to the DIY Honda Garage channel. This presentation focuses on the Diagnostic Trouble Code DTC P2126, which indicates that the Accelerator Pedal Position APP Sensor B, also known as Throttle Position TP Sensor E, is out of its operational range. The APP sensor is a critical component that translates the position of the accelerator pedal into an electrical signal, which the Engine Control Module, ECM, interprets to adjust engine performance accordingly. In a Honda Civic from the model years 2016 to 2021, the APP sensor is typically located within the accelerator pedal assembly. This assembly not only affects engine performance and vehicle acceleration, but also plays a crucial role in emissions control by ensuring proper throttle response. Diagnosing issues related to the APP sensor requires a systematic approach, as it is pivotal for many operational parameters within the engine management system. The Diagnostic Trouble Code P2126 indicates a malfunction related to the APP sensor B. This error specifically points to the sensor being outside of acceptable operational parameters. The affected components include the APP sensor and the Powertrain Control Module, PCM, which relies on accurate input from the sensor to manage engine performance. The APP sensor is located in the accelerator pedal assembly, which transmits signals reflecting how far the pedal is pressed down. The PCM, located in the engine compartment, processes this information to adjust fuel injection and throttle position, ensuring optimal vehicle operation. Any deviation in signals from the sensor to the PCM could trigger this DTC, impacting vehicle drivability and emissions compliance. There are several possible causes for the activation of DTC P2126. Poor electrical connections at the APP sensor or the PCM can lead to insufficient voltage signals, causing a malfunction indicator light to appear. Another likely cause is a faulty APP sensor itself, which may produce inconsistent readings or fail entirely. Additionally, damage to the wiring harness, such as fraying or exposure to contaminants, can also disrupt signal integrity. Each of these potential issues must be systematically evaluated during the troubleshooting process to ensure the proper function of the vehicle's throttle control system. When DTC P2126 is present, various symptoms may manifest, affecting the vehicle's drivability. Users may experience reduced engine performance due to limited throttle response, leading to a less responsive acceleration when pressing the pedal. This can be particularly dangerous in situations requiring prompt acceleration. Additionally, the accelerator pedal may become unresponsive at times, which can also compromise safety. Finally, the check engine light or similar warning indicators will typically be activated on the dashboard, alerting the driver to an underlying issue. Recognizing these symptoms is crucial for timely diagnostics and repairs. The first troubleshooting step requires verifying the issue by engaging the vehicle in the on mode, ensuring that all systems are powered. Following this, the technician should clear the DTC using the Honda Diagnostic System, HDS, which is essential for resolving any intermittent issues that may have caused the trouble code. After clearing the DTC, wait for at least 10 seconds before rechecking for any pending or confirmed DTCs. If DTC P2126 reappears, it confirms the sensor issue, indicating the need for further investigation. Conversely, if no DTCs are present, the issue may be intermittent, necessitating further examination of connections and terminals related to the APP sensor and PCM. In the second step, the technician must turn the vehicle to the off-lock mode to ensure safety while working on the circuit. After that, disconnect the APP sensor 6P connector. isolating the sensor from the vehicle's electrical system. Then, switch the vehicle to the on mode to power on the system without the sensor connected. Measure the voltage between the designated test points within the APP sensor 6P connector. The expected voltage should be about 5.0 volts. If this voltage is present, it indicates that the circuit is likely functioning correctly and leads the technician to proceed to the next troubleshooting step. Conversely, if the voltage reading is not correct, it indicates a potential issue that requires further investigation. For the third troubleshooting step, the technician must turn the vehicle to the off-lock mode to ensure a safe working environment. Next, the SCS/SRS control unit line should be jumped using the HDS for at least 1 minute to clear any system errors before disconnecting the next component. Disconnect the PCM connector A50P to isolate the PCM from the circuit. Then, check for continuity between specific test points in the APP sensor 6P connector and the body ground. Confirming continuity is essential because the presence of continuity indicates that there is a short in the VCC5 wire, which connects the PCM to the APP sensor. If continuity exists, the wire must be repaired to eliminate the short and restore functionality. The fourth step involves checking the continuity of the VCC5 line to confirm its integrity. With the vehicle still in the off-lock mode and both the APP sensor 6P connector and PCM connector A50P disconnected, the technician should measure continuity between the same test points identified earlier. If continuity is confirmed, this means the VCC5 wire is intact, allowing for proper signal transmission from the APP sensor to the PCM. If there is no continuity, it indicates an open circuit in the VCC5 wire, requiring immediate attention to repair the break or fault. This step is crucial in ensuring that electrical signals are being transmitted properly for the engine management system to function effectively. Step 5 requires another round of continuity checking, this time focusing on the SG5 line. The technician should continue with the vehicle in the off-lock mode and both the APP sensor 6P connector and PCM connector A50P disconnected. Continuity should be tested between the designated test points noted in the diagnostics. If continuity is present, it confirms that the SG5 wire is operational, thereby allowing for necessary signals to pass between the components. However, if there is no continuity, it indicates an open circuit in the SG5 wire, which needs to be repaired to ensure proper communication between the APP sensor and the PCM so that performance can return to normal. In the sixth troubleshooting step, the technician must again switch the vehicle to off-lock mode. Use the HDS to jump the SCS line, allowing it to reset any previous errors or malfunctions. Disconnect the PCM connector A50P to isolate it from the system. The technician should now check continuity between specific test points for the APS2 line, while ensuring the APP sensor 6P connector remains disconnected. Determining whether continuity is present in the wire is critical, as the presence of continuity suggests a short within the APS2 wire. If continuity exists, the wire must be repaired to restore proper functioning, while the absence of continuity suggests further checks are necessary. Step 7 involves conducting a continuity check on the APS2 line between designated test points while keeping the vehicle in the off-lock mode and both connectors disconnected. This step is crucial as it verifies whether the APS2 wire is intact. If continuity checks out, the APS2 wire is functioning correctly, confirming that this segment of the throttle position system is operational. However, if there is no continuity, It indicates an open circuit in the APS2 wire that must be repaired before moving on. Understanding the wire conditions is vital, as ensuring every segment is functional directly correlates with vehicle responsiveness and safety. The final step in troubleshooting DTC P2126 is to check the functionality of the APP sensor itself. To do this, substitute the original APP sensor with a known good accelerator pedal module. This substitution helps to conclusively determine whether the original sensor was faulty. After connecting the new sensor, all previous connectors must be reconnected to ensure a complete circuit. Exit the SCS mode using the HDS, then turn the vehicle to the on mode, and clear any existing DTCs with the HDS, waiting for 10 seconds before rechecking for both pending and confirmed DTCs will help to establish whether the issue has been resolved. If DTC P2126 does reappear, further investigation into the PCM may be needed. If, however, it does not reappear, the APP sensor is deemed functional, clearing the path for normal vehicle operation. Upon completing all troubleshooting steps for DTC P2126 and repairs, it is crucial to conduct a final verification of the repairs. The technician should recheck for the presence of DTC P2126 to assure that the issue has been fully resolved. If DTC P2126 does not appear, this indicates that the repairs made were successful, restoring the integrity of the APP sensor and its signals to the PCM. Furthermore, confirming the functionality of the APP sensor can involve a real-world performance test to ensure that the vehicle responds correctly under various driving conditions. This step not only solidifies the repair success, but also ensures the safety and reliability of the vehicle. Preventive maintenance plays a crucial role in avoiding the recurrence of issues like DTC P2126 in the future. Technicians and vehicle owners should regularly inspect all wiring related to the APP sensor for any signs of wear or damage, as frayed wires could potentially lead to short circuits or open circuits. In addition, checking for connector issues, such as corrosion or dirt accumulation, can prevent erroneous signals from affecting sensor performance. Ensuring that the APP sensor operates cleanly is also vital, as contaminants could impair functionality over time. Regular maintenance checks will not only help catch potential problems early, but will also extend the lifespan and reliability of the vehicle's throttle control system. In conclusion, understanding DTC P2126, which signifies that the APP sensor B is out of range, requires a thorough knowledge of the vehicle's electrical system. This troubleshooting process is designed to systematically identify potential issues, ranging from poor electrical connections to faulty components. Steps including checking continuity, repairing wiring issues, and substituting parts are essential for correctly diagnosing the error. Finally, preventive maintenance is crucial to ensure the vehicle operates without future interruptions related to throttle control. Addressing issues early enhances safety and performance, keeping the Honda Civic running smoothly. Please like and subscribe to the channel. See you next time.